Okay, let's now just try to solve these 5 questions. The first question, the previous video we discussed about the pH, the buffer, the equations that is related in how we can calculate the pH, the hydrogen ions, the pOH, and so on. So now these are the questions that I said we should consider them. Just make sure if you didn't watch the previous video, watch it so that you can know how we are deriving the formulas from. So now the first question says, what is the pH of 0.1 moles of acetic acid and 0.2 moles of acetic ion, given that pKa of acetic acid is 4.8. So now, what formula you going to use? Remember, for you to know which formula to use, you need to consider the data that is being given. The formula that we can use, it is pH is equal to the pKa plus log of the conjugate base over the weak acid. So when you write the formula, just plug in these values that has been given here. So for pKa value, it's 4.8 plus then the log of the conjugate base, it's 0.2, then over the weak acid, it's 0.1. So remember, master the formulas and then put the right values on that formula. So you need to know how you can identify the acid and also how to identify the conjugate base. So now let's try to find these. So the value, the pH, it is giving us 5.1. So this is the value for the pH. So now let's calculate the next equation, the next question. What is saying, what is the pH of a solution whose hydrogen ion concentration is 4.0 times 10 power negative 4 moles for per liter. So now, looking at the values that has been given, how can you calculate the pH? Remember, bring back those equations in mind. Which one are we going to use? Here we only have the hydroxide concentration and then we want to find the pH. So what are we going to do here? First, we are going to calculate the pOH, which is given by negative log, open bracket, negative hydroxide. So these are the concentration of hydroxide. So we are going to plug in this value of hydroxide concentration into this. Thereafter, we are going to consider to find the pOH. When we find the pOH, remember we said when we combine the pOH with pH, it gives us 14. So pOH plus pH, it is equal to 14. So when you find the pOH, we are going to subtract this pOH from 14 and then we are going to find the value for the pH. So let's plug in these values. So negative log. So here we are going to say 4.0 times 10 to the power negative 4. So here, remember, when you are dealing with logarithms, so this simply means that it's log. When you remove a negative here, it will be 1 over 4.0 times 10 to the power negative 4. So that's the expression that you can obtain when you remove a negative sign. So let's just try to compute this using the calculator. The value that I've calculated is pOH pOH is equal to 3.398, of which you can just leave it into 3.4. So now this is the value for pOH. So we know that pOH plus pH is equal to 14. So you can make pH, let's have the formula to calculate the pH. So minus, what is the value for pOH? It's 3.4. Is giving us 10.6. 10.6. This is the value that we have obtained. Let us consider question 3, which is saying calculate the hydrogen ion concentration or hydroxide ion concentration as required for each of the following solutions at 20 degrees Celsius and state whether the solution is neutral or basic or acidic. So the first thing that you have here is A, which is 10 not 10 rather, but 1.0 times 10 to the power negative 5. This is for the ions for hydroxide. But now we want to calculate the hydrogen ions, and then we need to state whether the solution is acidic, basic, or neutral. So now, which equation are you going to use? Remember the ionization constant of water, which is Kw. Do you still remember the value for Kw? It is constant. It is 1.0 times 10 to the power negative 4. Not negative 4, but negative 14. Negative 14. So using this value, we can calculate the hydrogen concentration using this formula. Remember, Kw is equal to the product of hydrogen ion and the hydroxide ion. So in this case, we have been given the hydroxide ion and we want to calculate the hydrogen ion. The K value we have already, it's 1.0 times 10 to the power negative 14, which is equal to, this is what we are looking for, hydrogen ion, okay, multiplied by hydroxide, which is 1.0 times 10 to the power negative 5. This is 10 to the power negative 5. So now let's make the hydrogen ion. Let's update the formula, which is, okay, we do this 10 to the power negative 5. Also here 0.2 times 10 to the power negative 5. So here cancels. So H ion is equal to, so we divide this divided by this. So this is 0.0 times 10 to the power negative 9. So this is the hydrogen concentration. So this is the hydrogen concentration. This is the molar. So now, remember the question says, state whether the solution, it is acidic, basic, or alkaline. So we need to compare, for us to assess if the solution is basic or acidic, we need to compare this value of hydrogen and hydroxide. So compare hydrogen ions and the hydroxide. This means that if there is more hydrogen ions, it means that the solution, it is acidic. Then if there is less hydroxide ion, it means that it is also acidic. But if there is more hydroxide ions than the hydrogen ions, it means that it's alkaline. So now when you compare this value to this value, which is here, which one is greater? This one is greater. So this simply means that this solution is basic or alkaline solution. Alkaline solution. Let's go to B. What are we having here? We have hydroxide again. So hydroxide of 1.0 times 10 to the power negative 7 molar. We want to find the hydrogen ions. So we are going to use the same formula, which is so this is the constant value. The constant value for Kw is equal to the value for hydroxide, which is 1.0 times 10 to the power negative 7. So we are going to make this one the separate formula, which is hydrogen ion. It is the one that we are looking for. So hydrogen ions, it will be 1.0 times 10 to the power negative 14 over 1.0 times 10 to the power negative 7. So when you divide using the calculator, you find that 0.010 to the power negative 7 molar. So now, when you compare this hydrogen ions and hydroxide here, is hydrogen ion greater or are they equal? So when both hydrogen ions and hydroxide ion are equal, it means that the solution is neutral. So we have got, this is the neutral solution. So now let's go to the last one. We have C, where we have the hydrogen ion of hydrogen ions of 10.0 molar. So it's this is hydrogen ion. So we want to calculate the hydroxide. So same formula, which is H plus then OH minus. So this is the constant value times 10 to the power negative 14 is equal to the 10.0 then times OH negative. So we're going here, in this case, we're going to make the OH the subject, the formula. So OH minus is equal to then 1.0 times 10 to the power negative 14 over 10.0. So let's use the calculator. That is 1.0 times 10 to the power negative 15. So this is the molar concentration of hydroxide ions. So now when you compare the two, which one is greater? Between the molar of hydrogen ions and also the molar of hydroxide? So we can see that the hydroxide ion is greater than this. So we can say that this solution is acidic. It's acidic. So thank you.